Hi everyone, it's Trinity, and in this video we're going to be going over spin, Hund's rule, and the Pauli exclusion principle. We're going to introduce each of these three topics as we fill out an energy diagram. And this energy diagram is just a cleaned up version of the energy diagram we drew at the end of the previous video. And we're going to be filling this energy diagram in for the element fluorine. So whenever you fill out an energy diagram, the first thing you want to do is pull up a periodic table and then locate the element in question. And you guys might remember that the electron configuration for fluorine is 1s2, 2s2, 2p5. And we will be coming back to the electron configuration later in the video, but for now, all we need to know based on this periodic table is that fluorine has 9 electrons because it's the 9th element in the periodic table. And we can use this fact to fill out our energy diagram. And we're also going to need to use 3 rules to figure out our energy diagram. And the first rule, and most important rule, is the Aufbau principle, which says that electrons fill lower energy orbitals before filling higher energy orbitals. So this means that our first electron is going to enter the lowest energy orbital, which is 1s. And we can represent this first electron as either an up arrow or a down arrow. And the reason we represent electrons as arrows is because electrons have something called spin. Spin is a type of angular momentum for electrons, and all electrons have either a positive spin, which we represent as an up arrow, or a negative spin, which we represent as a down arrow. Technically, the electron that first enters the orbital can be either an up arrow or a down arrow, but we just traditionally draw it as an up arrow, so that's how I'll draw our first electron. Now, let's draw our second electron. So, according to the Aufbau principle, our second electron enters the lowest energy orbital, which is the 1s orbital. But now the question is, does it enter as an up arrow or does it enter as a down arrow? And to figure this out, we're going to need to learn about our second rule, the Pauli exclusion principle, which says that no 2 electrons in the same atomic orbital can have the same spin. So since we already have an electron with positive spin, our second electron must have negative spin. And now let's enter our third electron. So according to Aufbau's principle, it wants to enter the lowest energy orbital, so you might think it'll go in the 1s orbital. But according to the Pauli exclusion principle, no 2 electrons in the same orbital can have the same spin. And since we already have an electron with positive spin and an electron with negative spin in the 1s orbital, and the new electron will have either positive spin or negative spin, it can't enter the 1s orbital. So the third electron will enter the next lowest energy orbital, which is the 2s orbital. And we'll draw it as an up arrow. Technically, it can be a down arrow either, we just typically draw the first electron in an orbital as an up arrow. And now let's enter our fourth electron. We know it's going to want to enter the lowest energy orbital, which is 2s, and we know from the Pauli exclusion principle it has to be a down arrow. Now let's enter our fifth electron, which we can see that the 1s and 2s orbitals are both full, so the fifth electron has to go in the 2p orbital. Now let's enter our sixth electron, and now we have a question. Does the sixth electron enter as a down arrow, or does it enter somewhere else? Like here. And to figure this out, we're going to need to introduce our third and final rule, which is Hund's rule, which says that as long as rule 1 and rule 2 allow, electrons enter with parallel spin. So we know from the Aufbau principle that the new electron is going to go here. And according to Hund's rule, it's going to want to have parallel spin. And since we already have a positive spin electron, that means our next electron wants to enter with a positive spin as well. And we know from the Pauli exclusion principle that we can't have it here because then we have 2 electrons with positive spin in the same orbital. So that means our 6th electron has to enter here. And by the same logic, our 7th electron will also enter here. So now let's enter our 8th electron. And according to the Aufbau principle, it's going to be in the 2p subshell. And according to the Pauli exclusion principle, it has to enter as a down arrow. And the same logic holds for our 9th electron, which will go here. So now we've entered all 9 electrons. So this is our final energy diagram for fluorine. And if you pay attention, you can see that we have 2 1s electrons, 2 2s electrons, and 5 2p electrons, which perfectly matches with our electron configuration. So now we're done with this video. I hope it was helpful. Thank you for watching.